fetching a value, and so that's the value that we're finding the limit at. Okay, so essentially what it boils down to is you're going to substitute this number into here, into the function, and find its limit. Okay, sometimes limits don't exist. Sometimes they may not start off existing, but we can figure out what it is depending on what it is. And they usually happen around asymptotes, so they're usually around undefined values. So a lot of times the value that we plug into the function initially doesn't work, because initially it'll say it's undefined, where you have to either divide by 0 or square root of negative. But there is ways to kind of fix that, so we can figure out the limit for the function, basically the value that the function should be at, even if it's undefined. We have to do a lot of factoring to help us out. So here's a quick review of all the different types of factoring that we might use in the next couple of examples. Okay, so one type of factoring is you can be given a couple of terms and asked to do a common monomial factoring, which basically means pull out what they have in common, and you can either pull out a variable or you can pull out a number. So that's what we're going to do with these two little examples here. Again, these are stuff that we've done in the past. It just may have been a little bit since we've done it. So I'm just going to do a quick review of these three types of factoring. So with this one, what do these two terms have in common? An x. So what we can do is we can take that x and pull it out in front, kind of like we did when we were solving for trig stuff. We can take the common cosine or the common sine out. We can take the common x out, and so then we write what's left over in parentheses. So it was an x squared, which means there's two x's. We put one x out in front, so that means there's one x left. And then here, this was a 2x. We took its x out in front, and so it has a 2 left over. So our common monomial was x. We put that out in front, and we put what's left over in parentheses. Now, most of the time we combine this with some other things, but this is a quick review of that type of factoring. So it doesn't always have to be a variable. It could be a common number. So like the greatest common factor. So what's the greatest common factor in that second? 4. So we can take out a 4 from that term. So you don't always have to take out a variable. You can take out a variable, a number. You can even take out a number and a variable at the same time. But that one has a common monomial of 4, and then we divide it out. So again, we had 4x here. We took 4 out in front, so we just have x left. And then we just divide it out here. So what's 12 divided by 4? 3. That's another way to do the common monomial. Okay. Always check your work. If you want to distribute that back in, you should get the exact same thing to start with. So x times x is x squared. X times 2 is 2x. 4 times x is 4x. 4 times 3 is negative 12. Okay. So that's one type of factoring that we'll use. Another type is perfect squares. Now don't get these two mixed up, because if you look here, we had two terms, both had something in common. You look here with an x squared and a 16, there's nothing in common. There's no greatest common factor, there's no x in both. So when we look and see if this number is a perfect square. Is 16 a perfect square? Yep. So then what we can do, it's kind of factor like we're going to do the trinomial, where you think about what multiplies to get the last number adds to get the middle. The big thing is that we're missing that middle x term. So the way we can factor this is by doing, what's the perfect square of 16? 4. So if we do x plus 4 and x minus 4, the reason why that works, if you take 4 times negative 4, is that negative 16? But if you add those two together, what's negative 4 plus 4? 0. So that's why there's no x in the middle. So that kind of relates it back to our other type of factoring we usually use a lot. Multiplies to get the last number, adds to get the middle, but there is no middle number, so it's like it's 0. So we multiply to get to 16, add to get 0. So the only way that works is with perfect squares, because they have a factor that's the same number.
But we don't solve it at all.
No. We're just practicing factoring. So this would work for 16. It would also work for 49, 25. So this only works when you have this second number a perfect square. And then this last type of factoring is one we use a lot. You have to multiply to get the last number, add to get the middle. So it's going to multiply to get 12, add to get 7, get 3 and 4. So x plus 3. So we're going to combine combine that with some other things as we work through our limits, but those are the main type of factorings that we need to remember how to do in order to work through these problems. Questions so far?
Is this hard, Richard?
I don't think so.
You think so?
I don't.
Oh.
I don't.
Have you said you
Did
did
you
it?
say
but she
the
said
last
that
one we did
about-
was hard?
I didn't say it was hard. I
She
said
thought it was
tedious.
hard.
Tedious. This is not.
Still was hard.
The last thing wasn't hard. It was the thing before that.
The last
The
thing
log?
was easy. I just kept messing
log
up.
stuff?
No, it wasn't the law. It was like kind of the law stuff. You know what I'm
I
talking
don't
about?
know that. I did that on
The
the
log
test.
stuff was
That's the one I missed like a bunch of points.
I just like
Oh wait. So we're asked to find the limit. Our first goal is just to be able to substitute the value, okay? So with our limit, we always have a value we're checking. So underneath our abbreviation for limit, we have x approaching a number. So this is where we're trying to find the limit at 2. So our ultimate goal is to be able to substitute that in and just get a number, okay? So if you can do that, that's all you have to do, and you can move on to the next one.
Wait, so the number.
For the most part, though, we pick numbers like this, where we plug it in, we get something that's undefined, or something that doesn't work. So like divided by 0, or something like that. So then we have to do our factoring, and I'll show you how that works here in a second. And then once you've factored, what you can do is you should have some common factors you'll be able to cross out, and I'll show you how that works here in a second. And then once you factor and then cross off some common factors, we substitute the value in again and see if we can actually find the limit with taking out the undefined value. Okay, so yeah, our first step though is you're always going to substitute this number in first, because sometimes it's just going to work and you don't have to do anything extra. I will tell you right now, we're working on one, so we have to do some extra, but always make sure you check the number first, because if you don't have to do anything extra, then you need to make sure you do that first step. So we're going to take 2 and plug it into my x's. So what's 2 squared? 4. We take 4 minus 4, which is 0. So you get 0 on the top, which that's fine. You get 0 on the top. 0 is fine on the top because we can divide anything by 0. We just can't divide by 0. What do we get on the bottom? 0. Okay, that's what makes it undefined. Okay, so that tells me I need to do something extra. So I'm going to take just the function, which is the x squared minus 4. I'm going to see if I can factor it. Okay, typically if you just have a single x, you can't factor that. But if you have an x squared, that should tell you I might be able to factor that. So I look here, I don't have anything in common because this is just an x squared, that's a 4. Is this a perfect square? Yep. What's the perfect square for 4? 2. So if you see a perfect square here behind something that's squared, I can factor that. It has to be subtracting in order for that to work. So I can factor that into x plus 2, x minus 2. And again, the reason why that works, 2 times 2 is negative 4, 2 plus negative 2 is 0x, so that's why we're missing that middle term. I can't factor that bottom because there's nothing in common between those two things, and it's not a squared, so that's going to say x minus 2. Everybody with me on the factoring step? Okay. So now, when I look, is there anything that you see that looks the same?
There's
Negative.
X minus 2.
X minus 2, x minus 2. So that would be a common factor that we can cancel out. Okay? So we can just cross those two things out.
The answer's 4.
So then
no. The answer is x plus 2.
2 plus 2
Okay.
is 4.
So now we're going to take what's left over, and now we're going to find the limit for just that small part of the equation. So once we've canceled that out, we're going to go back and plug our 2 in. So is this going to work if I plug 2 in now?
Yeah.
Yep. So what's my limit?
4. Can
that's
we
not
just?
too hard.
Hey, imagine this. Some of us have been gone for a while.
I mean, that was only the first problem
Yeah, I was gonna
too.
say, it starts out easy, and
Yeah.
then you throw some wacky crap in.
Exactly.
No, wait, questions about the first one?
Guess what I did over quarantine?
Sleep.
Spilled chocolate milk in my bag.
Oh, I saw that. That looks rough, Megan. How'd you fix it?
Not
So,
yet.
a whole lot better.
Was it like rotten?
It's like when your dad spilled milk in the backseat of his car. And that was so
smell-
terrible.
Haunts me.
Oh.
Alright.
That is a lot
My
of
mom
work.
sold her truck because my dad left a watermelon in it for 2 weeks. And so, and she
Alright.
didn't like the smell, so she got rid of the truck.
I wish
So our first step, take the value we're trying to find the limit at, plug it in, see if it works. If it works, we're done. Okay, if it doesn't work, get the
you
factor.
already said it's not gonna work, so.
Well, I said most of the time. Okay, so negative 5 squared
0.
minus or plus a negative 5 minus 20. So on the top I get 0. Okay, am I gonna get 0 on the bottom?
Yes.
Yeah, because let's negative 20 or negative 5 squared.
5 minus 5 is 20.
Yeah, so I have
20
25
minus
minus 5 minus 20. I get 0 on the bottom, so I don't have to factor. Okay, can I do anything to factor the top?
No.
No, because there's no squared. There's nothing in common with those two, so the top's gonna stay the same. Can I factor the bottom?
Don't ask me how.
Okay. So when I see three things like that, I'm gonna think to myself, okay, what multiplies to get that last number and adds to get that middle x?
Nothing. Wait. 5 and 4.
Yeah, 5 more, and usually a good hint, it might be related to the number that's already there. Okay. So what multiplies to get negative 20 adds to get a positive 1? Well, positive 5 and a negative 4. Okay.
Cancel it.
Now this one, we're gonna cancel it out. Now on the bottom, on the first problem, we canceled out the bottom. Technically, we should have put like over 1 there to show that we had a bottom to start with. But typically, if we put something over 1, we don't really worry about that. The reason why that's important is here, we're gonna cross off the top x plus 5. Now we need to make sure we still keep it a fraction, because that x minus 4 still needs to remain on the bottom. So what are we going to put on the top? A 1. Yep. So now we're going to find the limit as x approaches negative 5 for my new function. Okay.
1 over negative 9.
So I put negative 5 in for x, negative 5 minus 4. So 1 divided by negative 9. There's my limit.
So fractions are good to get to.
Yeah, you can get
Fractional
fractions.
numbers.
As long as you find a number. Alright, next one. Okay, I'm
It
just
doesn't
gonna
work.
check this one out loud. Okay. So if I take negative 3 times 3, negative 9, negative 9 plus 9 is 0. What's negative 3 squared? 9 plus 9 minus 9, 0. So I'm gonna get 0 out of over 0 again, so I have to factor. And like I said, we're kind of starting with the more difficult ones because it's not just gonna work right away when you plug it in. We will eventually, I promise, have ones where you just have to plug in the number and that's it. Okay? Right now we're kind of we're doing a little bit differently than we usually do in math. Usually we start with the easy stuff and work our way up. Here we're starting with more difficult stuff, and then eventually we'll go to the easier stuff. Okay. So now I'm gonna look to factor. Is there anything I can do to factor the top?
Yes.
Yeah, because there's again, we couldn't do anything up here because we didn't have anything in common. But here with the 3x and the 9, there's the greatest common factor there. So it's the greatest common factor between 3 and 9. 3. Yep. So I'm gonna factor the top. So it's gonna become x plus 3. The 3 out in front. Again, make sure you keep track of that 3 because it's still part of our problem. Can I factor the bottom as well? Yeah, because 9 is a perfect square. So I don't have anything in common because we have an x squared here and a 9, but 9 is a perfect square, so how can I factor that? Yeah, x plus 3, x minus 3. Okay. Is there any common factor I can cancel out? X plus 3. So I end up with 3 over x minus 3. Now I'm going to find the limit as x approaches negative 3 for that.
Negative 1 half.
Yep, so I put 3 and then negative 3 minus 3. So yeah, 3 over negative 6, which is simplified.
On this homework, are we supposed to do 27, 28, 36, even though it's the same thing?
Let me double check that.
Mm-hmm.
Alright, what do you notice that's similar about my next example than my original example?
The same exact.
It's the same exact same except for
It works.
I'm checking 3
So it's gotta work.
instead of
So
Okay,
it
so it
doesn't
still doesn't work. Okay, so we're gonna have to factor, but we can factor the same way we did on this third example. So 3 is gonna come out in front, and it's gonna be x plus 3, x minus 3. So we get 3 over x minus 3. Now we're gonna check the limit as x approaches positive 3. Okay. I got 3 over 3 minus 3.
Negative.
3 over 0.
So it still doesn't work.
Maybe write all that down for it to not
Okay.
work out.
So every once in a while, you'll do everything right. You plug it in, it doesn't work originally. Then you factor out what you can. You plug it back in, it still doesn't work. So what this means is that a limit
Oh.
Oh,
does
this is
not
mean girl stuff.
Exists.
exist.
Okay, there we go. It makes sense now. You just gotta
So if
put
you
it
ever
in.
watch Mean Girls,
Yeah.
this is what she's doing. Okay?
What
Not
the?
this specific album. But
Wait, actually?
yes, remember she
But
was
the limit does not exist.
limit does not exist. Okay,
That
now
makes both
you-
sense.
Existed.
Existed.
I thought I was just dumb and I would go.
So you say limit is not.
Limit is not what, Megan?
Is not existent.
Okay, what I usually do
Existent.
is use the abbreviation DNE.
I like it. I
Does not
like it
exist.
like that.
Okay, so that's usually what I use.
Is that how you spell exist?
No,
I don't think it is.
E-X-I-S-T.
Exists.
Exists.
See, now I really thought I was wrong. I was like,
Not
oh,
there you go.
Exists.
I spelled it the same way twice.
I was
Okay,
wondering.
spelling is hard.
Yeah.
You're a math teacher.
So
not
it's
a
well,
teacher.
first there's existed.
Your
and then next
husband
there's
exists.
She like automatically learned English.
Wow, you would think.
I don't know. I feel like we correct her over everything she says.
Well,
Is
it's
he
not
always correct you?
He's actually not very good at spelling either. He can spell words like exist though. Like I can't.
Can he talk?
Can he do that? Matthew do that?
I can't spell the word available for some reason.
You should
I don't
test
I
know.
can't
him.
spell definitely.
Me either.
Alright,
Look at the E in
now-
the
we got 2 more examples and we're done. Okay, every once in a while you plug it in, it doesn't work, and you can't factor. If that happens,
Oh, me shut my head.
we have to plug something in Death Note.
Yep. You don't have to snip the graph, but you will have to look at the graph. Okay? There is a nice app on your phone.
There is?
Yep, if you want to get a Decimus app, you can use it on your phone.
I'm
Okay.
going to.
But yeah, we plug this in, okay? We get 0 on the bottom, right? We put 0 in there. I don't know what sign. I think sign 0 is actually 0, and then over 0.
That was cute.
So this one's gonna be 0 over 0. So we're gonna look at the graph. Now you do not have to type the whole sign or the limit part of it. You just have to type sine of x divided by x.
Shark, can you just not give us?
We do
these?
X, we don't put zeros in their spots. Okay.
I thought we were done with copy.
Probably never make
God,
it.
I hoped we were.
1 through 6, 14 through 18, 27, 28, 36. Wow.
So if we look here,
Why does it look like that?
so this is sine of x over x. So what we're worried about is 0. Okay, see if I can get there. So see if I put my point right at 0. See how it says it's undefined? But notice on either side of it, it kind of looks like it's going to a number. What's that number? 0.999 or close enough to 1. Okay? So if you look at your graph, like I said, if you specifically look at 0, it's undefined. What on the value on that graph, what does it look like it should be? 1. So then I can say my limit equals from there. Okay? Now if it still looks like it's going to something totally different, then we don't put a number. But if it actually looks like it should be 1, there's just a hole there, we can say the limit's 1. Okay? Now to check this one, 2 squared is 4, 4 minus 4 is negative 1. Okay? 2 minus 2, we get negative 1 over 0. Again, can we factor this as 5 a perfect square?
No.
No. So this tells me I can't factor it, so I'm going to have to look at its graph. Does that make sense?
Sure.
And again, don't
Would you
snip the graphs,
calm
just
the
have to use
heck
your
down?
calculator. So here, I've looked at the graph.
Come sit over here.
So, listen. Okay. So we have x squared minus 5 over x minus 2. Okay. The value we're looking at is 2.
Why 2?
Okay, because that's what I told you to look at.
Oh, the limit?
Yep.
Oh, okay. I gotcha.
It's okay. So here's 2. Is there anywhere the graph is at 2?
0.
No. Okay. So with that last curve, it was a nice even curve. It just had a hole with this one. This one is kind of going off in all different directions at 2. So if you look at this one, it's never going to get to 2. This value never gets to 2. So this limit does not exist.
If you say so.
Does that make sense?
Yeah.
Okay, so if your graph's going every which way at that value, so it's not really a nice smooth curve like our sine of x was. We can say a value for sine of x because it was a nice smooth curve, it just had a hole in it. This one's going all different directions at 2. So the limit does not exist.
Can we borrow your book to take a picture?
It's like